Welcome to our video presentation.
For today's video, we will discussing about
Sector and
segment of a circle. So, Gracie, what is a sector of a circle?
a sector of a circle is the region bounded by an arc of the circle and the two radii to the endpoint of the arc. The two radii, they are the radius of the circle, and as you can see, there's a shaded part of the circle. That shaded part is what we call the sector of the circle. So how can we get the area of it? If we will get the sector of it, it will be called sector XYZ. We need this to solve the problem, which is what we're looking for, the area of sector XYZ. So how can we solve it? Let's have an example. First, we will get the ratio of the part of arc XZ. Arc XZ is equal to 60 degrees to the whole arc of the circle, which is 360 degrees. When we get the ratio, we will multiply it to the area of the circle. So what we need is the ratio 60 degrees out of 360 degrees. And then the area of the circle. If we will get the two, we will multiply them and the product. After that, the answer will be the area of sector XYZ. When we get the ratio, we will multiply it to the area of the circle. So what we need is the ratio 60 degrees out of 360 degrees. And then the area of the circle. If we will get the two, we will multiply them and the product. After that, the answer will be the area of sector XYZ. Okay, so we will start with the ratio. Ratio of 60 degrees out of the whole circle, that is 360 degrees. So 360 degrees divided by 360 degrees, reduce to lowest term, that will become 1/6. Next, we will get the area of the circle. A is equal to pi r squared. R is the radius. Let's substitute the given. Our radius is 10 cm. Simplify 10 cm squared, that will become 10 squared pi square centimeter. Then 10 squared is 100 pi cm squared. Now, our area of the circle is A is equal to 100 pi cm squared. Now, we have our ratio and area of the circle. Now, we are going to get the product. The ratio is 1/6. Let's multiply it to the area of the circle, 100 pi square centimeter. Just multiply the 1 times 100 pi square centimeter. It will become 100 pi square centimeter all over the denominator 6, and then reduce the lowest term if needed. So 100/6 can be simplified to lowest term. A common factor is 2, so 100 divided by 2 is 50, 6 divided by 2 is 3. 50 pi over 3 square centimeter. This is the area of sector XYZ.
So, what's about the segment of a circle? Segment of a circle is the region bounded by an arc and the segment joining its endpoints. So it means, in our illustration in circle N, the line segment NP and arc MP is the one inside with the shaded part. It is what we call a segment of a circle. So how can we get the area of a segment of a circle? For us to get the segment of a circle, first we have to get the area of a sector M and P, and we will subtract to the area of the triangle. So the difference of it is the area of a segment MP. Let's have an example. find the area of a shaded part. So first, for the area of M and P, so again, first we will get the area of an arc to the whole arc. First, we will get the ratio, 90/360. Reduce to the lowest term, that will become 1/4. Next, the area of a circle. So, the formula is A equals pi r squared. The ratio is 6 cm. Let's substitute the reduced to 6. So that will become A equals pi 6 cm squared. So let's distribute the squared. That will become A equals pi 6 squared centimeter squared. So what is A equals pi x squared cm squared? That will become A equals 36 pi centimeter squared. Then we will multiply the ratio and area of circle for area of sector M and P. The radius is 1/4 multiplied to the area of a circle, 36 pi centimeter square. So 1 times 36 is 36 pi over 4 centimeter square. So 36 divided 4 can be reduced to the lowest term. 36 divided 4 is 9 pi centimeter squared. So 9 pi centimeter squared is the area of sector of M and P. Since we got the area of a sector M and P, which is 9 pi centimeter squared, now we will get the area of a triangle M and P. And for the area of a triangle M and P, that is equal to 1/2 base time height. Actually, at our triangle, the base is reduced and the height is reduced, so they have the same base and height, which is 6 cm. So, if we're going to substitute, that will become 1/2 base is 6 cm, height is 6 cm. And simplify 1 times 6 times 6 is 36 over 2 cm, and then divide 36 divide 2 is 18 cm squared. So that is the area of triangle. So we got the area of a sector M and P and area of triangle M and P. Now we will subtract the area of sector M and P and area of triangle M and P. So for the sector, 9 pi centimeter squared minus 2 area of triangle 18 centimeter squared. So let's simplify first the 9 pi. 9 times pi is 28.27 centimeters squared minus 18 centimeters squared is equal to 10.27 centimeters squared. So that is the area of a shaded segment.